So those are 3 ways we can prove triangles are congruent. To that, we are adding 2 more, and these are the final 2. The one that we're actually using today, though, is side, side, side. Okay, was side, side angle one of them? Remember we talked about this last week, or maybe the week before that even. If it makes the bad word, it's not one of them, right? Okay, do you guys remember the other one that was not one of them? Yes. We mentioned this once or twice also. This does not work because maybe these 2 triangles have the same angles, but are they congruent? No. This one's twice the size. So these don't work. So these are no-nos, but these do. So we're adding side, side, side to the list. Also, they didn't really introduce this one today, but I want to introduce this one today. There is one more, and it applies to right triangles. It's called that. What do you think that stands for?
What's the word? Forgot it. Hypotenuse? Yeah, it's the thing that goes across.
Okay, so normally if I had this, what would that be? Angle, side, side. Is that one of them?
Bad word.
It's a bad word.
No.
That's not one of them. But in a right triangle, it turns out it actually works, but they don't call it that. Because it only works in right triangles, not the other kind. They call it this, and yes, you guessed right. It's hypotenuse, leg. So you guys remember which side was the hypotenuse? The long side. And the short side was the leg. Shorter sides were the legs. What if instead of that, what if I had this, what would that be? Side angle side. Okay, so just because it's a right triangle doesn't mean it's hypotenuse leg. It still could be side angle side or angle side angle. But hypotenuse leg is something that works on right triangles that doesn't work on anything else. So I'll add it to the list just to finish the list. I'll remind us tomorrow because tomorrow we're actually doing right triangle stuff. But for today, really, it's just these 4 that we need. All right. I don't need to erase that. Computer's slowing down. Okay. I'm way off. Oh, yeah. One other thing before I get going. You guys remember what we knew about, what kind of triangle is this? Isosceles. What do we know about isosceles triangles besides it has 2 equal sides? The base angles are congruent. They call that the isosceles triangle theorem. And what if we knew that these 2 angles were congruent? The opposite sides were congruent. Okay? So they called that the converse of the isosceles triangle theorem. But basically you could just say if 2 angles are congruent, they're opposite. The sides opposite of them are congruent. What else? I'm forgetting something. Maybe I'll flip back my book and it'll remind me. Oh, I remember. What's angle 4 called? Exterior angle. What do we know about exterior angles?
That's the sum of 1 and 2.
Angle 1 plus angle 2 equals angle 4. Yeah. Exterior angle theorem. Or what do we know about 3 and 4? They're supplementary. Yeah, okay, you guys remember that stuff. All right, now we're on page 180. So, on number 1 it says, if the triangles can be proved congruent using side, side, side congruence, write a valid congruence statement. What does that mean, write a congruence statement?
Something is congruent with something.
Yes, something is congruent to something else. If the triangles are congruent, we're supposed to say this triangle is congruent to that triangle. We've done this, this is like the 4th or 5th time. If not, if we don't know the triangles are congruent, state an additional side congruence that would enable the triangles to be proved congruent. So if we don't have enough information, we have to add the information to say this is the fact that's missing, basically. On number 1, do we have enough information to say those two triangles are congruent by side, side, side?
Yeah.
Well, I see that AB is congruent to BC and AD is congruent to DC. Do we know that BD is congruent to itself? Yeah, do you remember what we called that when we said reflexive property? We're going to need that later. So I have enough information to say these two triangles are congruent by side, side, side. So if I say triangle ABD is congruent to triangle, and then what would the order have to be for the second one? If I go ABD, CBD. All right. Number 2 is a bit of a trick question, so let's look at it. Do we know that those two triangles are congruent?
No.
No. Why not, Shannon?
They don't have two lines.
Okay, yeah, what they're saying is the first triangle, all its sides are congruent to each other. The second triangle, all its sides are congruent to each other. But does that mean the two triangles' sides are congruent
No.
across the way? No. So basically it could be like this triangle and this triangle. All these sides are congruent to each other, all these sides are congruent to each other, but that doesn't mean these are congruent to these. So what would I need to know to say these two? Basically they're what kind of triangles do we have? Equilateral. What would I need to know that this triangle is the same as that triangle? What fact could I know? Well, okay, let's say I knew this side was 5 long, then what would I know? What else?
Rest are 5.
The rest are 5. Okay, so if I knew just like one of these sides was 5, then the rest would have to be 5. So really I just need one of the sides to be congruent. So you're supposed to state a missing fact that would help you prove it. So you just need to say like segment AB is congruent to segment DE or something. Any side is congruent to any side on the other triangle. All right. Number 3, do I have enough information to say those two triangles are congruent? Well, what are those two angles in the middle called? Vertical angles. So basically we've got side-side angle, right? But is that a thing? No. So we're missing the third side. So what fact do I need to know for the triangles to be congruent?
TR is congruent to RQ.
Okay. QR is congruent to RT or something like that. So notice that the triangles are twisted around. That happens a lot on the bow tie questions. The bottom or the top left side is like the same as the bottom right side, or the bottom left side is the same as the top right side. So it's a twisted bow tie. That's very common. Okay, number 5. This one's probably the hardest one. Do I have enough information to say these two triangles are congruent? What kind of triangle is that on the left? The left triangle. What kind of triangle is that? You see how it has 2 equal angles down at the bottom? So it's an isosceles triangle. So that means PQ must be the same thing as QR. And QR is the same thing as RS because they told us. They marked them both. And the triangle on the right also is an isosceles triangle because it's got 2 equal angles. So RS must be the same thing as ST. Well, so all we're missing, so those four sides are congruent to each other. So that's like two pairs of congruent sides. But do we know that PR is congruent to RT? Well, if we would have read the problem, we would have, because it says in the beginning, R is the midpoint of PT. What does it mean if R is the midpoint of PT? If R is right in the middle, then PR and RT have to be the same, right? By definition of midpoint. R is in the middle. So, do we know all the sides are congruent? Or have congruent corresponding sides? Okay, maybe I should have written it instead of just talked. Now let's go down here, guys. So here's what they told us. Those two sides are congruent. But since these two angles are congruent, this has to be an isosceles triangle, so that's congruent. And because these two angles are congruent, it's an isosceles triangle, these two have to be congruent. So these two are the same as these two. And because R is the midpoint of PT, that means these two have to be congruent. So do I have enough information?
Yeah.
Side, 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 side. Yes, I do. So, in other words, all that to say the triangles are congruent. Triangle, if I go PQR, that would be congruent to TSR, yeah. Actually, yeah, those, you could actually flip the order because they're isosceles triangles, but yeah, let's go ahead and read TSR. So we could have put RST also, because isosceles triangles are, if you flip them, they're still the same both ways. Number 6, okay, here's another mess. Do you guys see the two triangles? There's kind of 3 triangles in the picture, but they're talking about 2 of them really. Okay, so there's one big triangle that looks kind of like that. And there's another big triangle that looks kind of like that. And my picture looks a little different, but it's basically the same thing. So, do you guys see the 2 triangles? There's kind of a triangle there and there, but really what they're talking about is these 2 triangles. I think they don't overlap quite. Yeah, that looks better there. Looks more like that. Because there's a little bit of gap there. Okay, one thing that they told us is that these 2 sides are the same. So, you see this bottom side of the left triangle from here to here?
Yeah.
Notice it's made up of this little thing right here plus this. And if you look at the bottom side of this right triangle, it's made up of this little thing plus this. So they're both equal to whatever this is plus this. So the bottom sides have to be congruent. Okay, they told us just from here to here is congruent, but that's not really the whole thing. But since I know these 2 angles are congruent, then I know those 2 parts are congruent. So this 2 plus 4 equals 2 plus 4, so these long sides are also congruent. So all that to say, yeah, those 2 triangles are congruent. You just got to put them in the right order. Triangle, the big triangles are congruent. Okay, number 7. Consider the following 6 conditions for exercises 7 through 12. Side, 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 side angle, blah, 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 blah. Which of the listed conditions can be used to prove 2 triangles are congruent? So what they did there is listed all the possible combinations of sides and angles. Which of those actually work is what they're asking. Side, side, side works. Side, angle, side. Does angle, angle, angle? No. Does angle, angle, side?
Yes.
Yes, that was Tuesdays. Does angle, side, angle?
Yeah.
that's all of them. Now, which did we talk about that's not on this list? HL, that's on this list. Okay, number 9. Explain why two triangles must be congruent whenever two pairs of corresponding angles and one pair of corresponding sides are congruent. So, they said two pairs of corresponding angles, that's one pair. This is two pairs. Two pairs of corresponding angles are congruent, and one pair of corresponding sides. Let's say it was these two sides. Do I know these two triangles are congruent? Do I have enough to say these two triangles are congruent? What do I have? What? Angle, angle, side. Okay, but what if it wasn't those two sides? What if it was these two sides? Angle, side, angle. What if it wasn't those two sides? What if it was these two sides? Okay, is angle, what would angle, angle, side be the same thing as?
Side angle.
Side, angle, angle. So either, if we know two pairs of angles are congruent and one pair of sides is congruent, either angle, angle, side or angle, side, angle applies. That's the answer. So either angle, side, angle, or angle, angle, side applies. Depending on where the side and the angles are. All right, now it's happy, happy fun time. No fun, I forgot. Broke my rule.
Well, you have to write the rules 1,000 times, huh?
You gotta write 10,000. You have to write them both.
Well, I'm a dictator, so I don't obey my rules.
Oh, man.
Okay, we're doing 17, which is a proof. Paragraph proof just means like you talk through it. We're not going to do that. We're going to do standard proof. Well, guess what comes first? Well, I mean after the given. What is given on number 17? AB is congruent to CD. AD is congruent to CB. Those are the things we're assuming are true, so that's kind of like the given. Let's see, can I squeeze that drawing in over here? ABCD. Okay, so the given is AB and CD are congruent, that's those two, and AD and CB are congruent, that's those two. Do we have enough information to say these, well, we're trying to prove the triangles are congruent. Do we have enough information to say the triangles are congruent? No. What do we have so far? Side, side. So what else do we know is congruent just by looking at the picture? BD is congruent to itself. BD is congruent to BD, and that is called reflexive property. Well, that's right, reflexive. There you go. All right. Do I have enough to say the triangles are congruent now?
Yes.
Yeah, what do we got? Side, 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 side. They both have three pairs of congruent sides. So I'm ready to go ahead and say, it's a really short proof. Triangle, I'm just kind of copying it from the book. ABD is congruent to triangle CBD. By side, side, side. Okay, that is the side congruent to itself. That's a very common trick, and probably there'll be. And here's the other very common trick. What do I know is congruent in these two triangles just by looking at the picture? The vertical angles. Okay, that's the other very common trick. Pretty much guaranteed one of those things will be on the test, like one where you have to use a shared side or a vertical angle. Okay, number 18. Statement. Reason. Oh, speak of the devil. Here comes a bow tie problem. Hijkl. Okay, what goes on line 1? Right, HK and LI bisect each other. I did half of a lowercase b and half of a uppercase b. Anybody witness that? I did that. Half lowercase, half uppercase. HK and LI bisect each other. Reason?
Why don't they just give us all the information?
Yeah, why not? All right. What does it mean that HK and LI bisect each other? What does bisect mean? Cut in half into two equal pieces. Now, probably I would say it's okay just to go ahead and say these pieces are equal because they're being cut in half. That's the definition of a segment bisector. But the book would probably do an extra step. I'm going to go ahead and do the extra step. If HK and LI are bisecting each other, then that means that J is what would J have to be? Midpoint. And how do we know that? Definition of segment bisector. There's also an angle bisector, cuts an angle in half. So we have to be a little bit specific. So that's the definition of bisect, that they go through the midpoint. But if J is the midpoint, I probably should have said of both of HK and LI. Let's be clear that it's the midpoint of both. If J is the midpoint of both, then what do we know? If J's in the middle, these two are congruent. If J's in the middle, these two are congruent. So that's kind of the next thing we need to say. HJ is congruent to, what was it? JK? JK. All right, and then what else? IJ and JL? How did we know that was true? Because J is the midpoint, that's what midpoint means. It splits it into two. So guess what I'm going to write? Definition of midpoint. In other words, that's what midpoint means. Do we have enough information to say these two triangles are congruent yet? No, what do we have?
Side.
Side, side. What do we, What else? The vertical angles. What are the vertical angles? What's this vertical angle called? HJI and LJK. Angle HJI is congruent to angle LJK. Because now do we have enough to say the triangles are congruent?
Yep.
By
Side
side angle side, side angle side. Okay, so I'm just going to copy the proof statement they wrote down here. So triangle HJI is congruent to triangle KJL by side angle side. Number 19. Okay, what's given on 19? Angle M is congruent to angle P, comma, angle MNO is congruent to angle PON. So we need to fit that picture down here. Okay. MNOPQ.
I understood that.
All right.
But these are yours.
Are we trying to prove triangles are congruent? Yes, we are. You guys see the two triangles. It's kind of like number one of the other numbers. Okay, we're talking about the two big triangles. So that would be these two. Got it? So let me mark the given down. It says angle M is congruent to angle P. So that would be these two. Maybe I should draw them separate down here. Might help. And angle MNO. You guys see angle MNO?
Yeah.
And angle PON. That would be these two.
So we need the bottom side.
Okay, do I have enough information to say these two triangles are congruent?
No, we need the
Got angle.
middle side.
Okay, what else is congruent between these two that they didn't tell us?
Any side thing.
Okay, we could say this angle is congruent because if two pairs are angles are congruent, third pair is congruent. But does angle help us? No. So what side is congruent?
The two sides opposite.
Be more specific. Between the thingies is not helpful enough.
Those.
You could name it using this picture.
Oh shit. The only way I can describe it is the thingies. That's,
What's the same on both these triangles?
Oh, the base.
The base, right?
You should write it wrong.
Okay.
You should
Well,
do it hard.
or you could just add segment NO, right? No. Okay, number 2, segment NO is congruent to segment NO because reflexive.
No. asked me to bring it. $20 each trip.
Hey, Grant.
Oh, really?
Yo, bro.
Is this you?
All right. So we just said that's congruent to that. Do I have enough information to say the triangles are congruent? What do we got? Angle, angle, side. So triangle, what? M and O
Nothing.
is congruent to triangle PON by angle, angle, side. That was a short one. Seems like the evens are longer.
You're just weird today. What? You've been such a weird
Olivia, you're just always weird.
He's got to make up for Grant being gone.
Yeah.
Oh, yeah. That's the seat.
He's, yeah,
True.
the seat is
That's
contagious.
the natural thought and the power of congruence words.
Okay,
It's been
How do you
passed
feel
down.
about that part? How do you feel about sitting in his part?
I'm proud of it.
Oh, okay.
Being Greek is contagious.
Okay, numero 20. I'm not going to do all this one, but I will help. No, it's not bonus. Okay, you guys can do it though. So this one's different than the rest because we're not trying to prove, the final goal is not to prove the triangles are congruent. The final goal is to prove that the top and bottom lines, AB and BC or AD and BC are parallel. How can we tell if two lines are parallel or not? How do I know if these two lines are parallel?
That's simple.
The lines where or the thingies are congruent on them. Different ways the angles are congruent.
Okay, what kind of angles are these right here? Alternate, interior. You guys see it if I extend these lines? You guys remember alternate interior angles?
Quit it with the pen.
If these alternate interior angles, we say interior, if the alternate interior angles are congruent, then the lines have to be parallel. So, how do you think I can, no, I'm trying to make it look more like the picture. If I go back and draw these lines in, now it looks like this. How do you think we could prove that these two angles are congruent?
What? You measure.
No. If we can show that the two triangles they're in are congruent, then any matching parts in the triangle have to be congruent. Does that make sense?
Yo.
If I can say this triangle is congruent to this triangle, therefore these two matching angles have to be congruent. And once I say the matching angles are congruent, I can say these lines are parallel because alternate interior angles are congruent means the lines are parallel. Okay, so what that means for you guys, lines 1, 2, and 3 are show the two triangles are congruent. Line 4 is where I'm going to help you, is say that these two angles are congruent. And then line 5, the final line, is say that the lines are parallel. So what are these two angles in the picture? I don't know, what are they called? What's the name of the angle?
Q.
Can't call it angle Q.
Oh wait.
There's no Q also.
CAB.
Okay, yeah, angle BAC, BCA, whatever. You can call them different things, but angle BAC. No, sorry. That's the wrong ones. Those are the ones that are given to us. We don't need that. We need this angle. So maybe somebody said it right. What's this angle called in the picture? ACB. Is that what you said? Let me write the letters in, that probably help. A, B, C, D. So this is called angle ACD. As you're saying it, you're basically drawing the angle. A to C to B. It draws this angle. So angle ACB is congruent to what? DAC, yeah. Okay. Why do we know that? Question mark? Confused face emoji? Is that an emoji?
I think so.
Or maybe there's one where it's like,
If only that one
What's
video.
wrong with the question mark? Can you do that again?
Put on video.
But like,
Yeah, walk into the frame, walk into the frame.
if you guys got nothing better to do than watch me do that on video.
we will clip it and spread it.
We're making it, that's why our YouTube channel. We're gonna make a huge sticker and put it on our wall.
Yeah.
Okay.
We did that.
Okay, the reason we're going to know this is true is because at this point on line 4 we'll know the triangles are congruent. And if the triangles are congruent, listen, if the triangles are congruent, then we know that their matching parts are congruent. Does that make sense? So up here on line 3 we will say the triangles are congruent. On line 4 we can say therefore these two angles are congruent because they're matching parts of congruent triangles. Or in other words, corresponding parts of congruent triangles.
Isn't there another letter?
The book writes it as CPCTC, corresponding parts of congruent triangles are congruent. But I don't. The last, it's implied. Okay, now, the fifth line is what we were trying to prove,
Stop.
which is line AD
Yeah.
is parallel to line BC. And how do we know that's true? Because what kind of angles are these in relative to the lines? Right, because if alternate interior angles are congruent, the lines are parallel. I'll just put alternate interior angles are congruent. Okay, that just leaves you with lines 1 through 3, which are very similar to 17 and 19, so it's slightly different than 17. Alright?
Yes.
Each line will be worth a point, so you probably don't want to skip that one.
A point, not half.
Even the given line's worth a point. What?
Not just half a point.
No. No. We're about out of time.